Hello everyone, this is Umashankar Ratnala. In this session, we are going to discuss about some of the basic activities in Integration Cloud Service. These are the list of activities which are covered over this session. Any programming language, if you want to write some conditions, exceptions, so every programming language provides some of the activities. For example, for each activity, while activity, if condition, exception handling. It is common for each and every programming language. In the same fashion, Oracle Integration Cloud also provide some of the activities which we can use these activities for building the integrations. Let's get started. Right, as you can see, we can have lot of actions: data actions, call actions, collections, general, and right. We can discuss each and every action in detail. Let's start with the data selection. So in the data selection, we can have assign, B2B, data stitch, map, and stage file. So by using assign activity, we can create variables and we can assign the values as per our requirement. In Oracle Integration Cloud, we can use the expression builder and you can assign the values. Right. So in OIC, we have two types of variables. One is the local variable and second one is the global variables. So you can directly create a local variable, so you can assign the values, but whereas while creating a global variables, you have to assign the values by using the data stitch operation. Okay. So in OIC, directly you can create a local variables as per our requirements. So next activity is B2B, or you can call it as a EDI translate. So basically we can use this activity to translate an XML message to EDI format. So in the real time, so we will receive the EDI documents from the customers, right? We will receive the document in OIC integration. We will convert that XML message to an EDI external format. Right. So EDI is nothing but electronic data interchange format. So basically we can use this functionality to convert the XML messages to an EDI external understandable format. Next one is the mapper. Basically we will use the mapper to map your source to target systems. You can map the source values to the target values. So next one is the stage file activity. A stage file in Oracle Integration Cloud is a temporary location, or you can call it as a virtual location that is used to store the data during an integration flow. So in the real time, we have a requirement where we are going to receive the file from the source system. We can place the file in a virtual location and then we can use that file for the further processing, or you can send to the downstream. Right. So basically stage files are created by the OIC engine and the files are deleted automatically when the integration flow is completed. Okay. So this is very important flow, and in the stage file activity we have we could see other operations like list, write, zip, unzip, encrypt, decrypt, read file in segments. These are the operations based on the our requirement. We can use these operations. For example, you have received a multi files, but you want to combine all the files, then you can use the zip file. If you want to unzip the file, you can use the unzip operation. So whenever you are receiving the file, you are sending to the OIC application, you can encrypt it, and while sending to the third party application, you can decrypt again. Alright. So these are the various operations we can discuss in the further sessions. Right. Next one is the data stitch operation. So data stitch basically whenever we have a complex variables assignment, then we can use the data stitch operation. Right. So data stitch operation already works with the global variables. In data stitch operation, we could see the different operations like you have assign activity and append activity and delete activities. So next one is the call activity. Within the call activity, you have integration and JavaScript and process. So in the integration, you can create a child integration, and also you can expose the child integration as a part of your main integration. Right? Let me go through an example. So we have an integration where it supports to create a PO receipt and also inventory adjustments. Right? In the inventory adjustment, you can perform the intra-org transfer, sub-inventory transfer kind of transactions. Based on the PO receipt type, you have to invoke the web services. In case of your receipt type is the PO creation, you have to call the web services one. In case of your receipt type is the inventory adjustment, you have to call the web services too. In that scenario, you have to create you have to build a separate child integration for each and every web services, and you can make use of these web services in your main integration flow, right? It will give the higher performance, right? So by calling this integration, it will give the feasibility to work like a microservice approach. It will eliminate the additional connections for the integration endpoint. As a result, it will optimize in call memory. Okay. So next one is the JavaScript. Using this JavaScript function, which we can write some custom logic for transformation purpose, which cannot be achieved through ICS. In some scenarios, we have to write some custom function, custom logic, which is not available in ICS to support that functionality, right? In that scenario, you can prepare a JavaScript, you can prepare a Java library, you can upload that file in ICS, and you can call the script in our integration flow, right? So you can write your own logic using your Notepad++, right? You can prepare a JavaScript and you can load it to ICS, and you can make use of the JavaScript service, right? We can discuss in the real-time sections. Next one is the process. Right, this process is nothing but you have a process application, but you want to call it as an integration, right? So for that purpose, you have to create a process, right? So next one is the collections. Within the collections, we have for each activity, scope activity, switch activity, and while activity, right? So for each activity, like other programming language, you have to iterate the each and every element. Right, you can loop over a repeating element. In that scenario, you are going to use the for each activity. Your payload contain 10 records. You want to iterate each and every record, and you can transform the data to a downstream application. In that scenario, you are going to use the for each activity. Okay. Next one is the scope activity. Scope activity, it is like it's like whenever you wanted to define your own fault or your own exception for particular logic, you can define a scope. Okay, so scope basically enables you to manage a collection of child actions and invoke that can have their own fault handlers, right? So in the real time, we have a requirement where we can write the multiple validations, right? So in that scenario, for each and every validation, we can create a scope, and within the scope, we can raise an exception. So in PL SQL, when you are writing a code, you will prepare a each and every block. Each and every block, you can write a select statement. For every select statement, you can have an exception. Similarly, for each and every validation, we can create a scope activity. Within the scope activity, you can catch the exception, right? So next one is the switch activity. It works like a if-else condition, like other programming language. So if condition 1 is true, then we are going to execute the statement 1, right? If the condition 1 is false, it will go to the second statement and it will execute the second statement. Else it will execute the third statement. All right. So whenever we are writing any decision making statement, we can use the switch activity. All right. So next one is the while loop. Like other programming languages, while loop, which will keep executing till the time a specific condition is not fulfilled. That means, for example, we have a condition like 1 less than or equal to 3, right? So whenever this condition fails, the while loop execution will get end, right? This is the advantage of the while loop. So next one is the general section. Within the general section, we have logger, note, notification, and wait. Let's start with the logger. So basically, logger will help you to enable the debug messages, right? For example, in other programming language, we can enable the debug messages. In Java, we can write something like system.out.println, right? So whenever we wanted to enable the debug messages in Java, we can use this statement. See, in the similar way, whenever we wanted to enable the debug message in PL SQL, we can use the dbms_output.putline, right? Similar way, in OIC also, by using logger activity, we can enable the debug messages, right? We use this logger to validate some set of information. We can understand what was the value at particular point of time, right? That is the importance of the logger. So next one is the note, right? So note basically this is really handy to add some developer notes at design time, right? It's similar to a comment or placeholder to consider about future course of actions to be done. Right? So when you are dealing with the any integration development, you can add some placeholder to understand what value is coming at particular point of time, and you can understand the logic when you check it at later point of time. Okay, that is the advantage of note. Next one is the notification. So whenever you wanted to send some email to the business, right, we can use the notification. In the notification, you can enable your from address to address and subject, and you can write body, and also you can enable the parameters to assign some values, runtime values. Okay. So next one is the wait activity, right? So like other programming language, the wait action enables you to delay the execution of an integration for a specific period of time. So when sometimes you are trying to call a web services, but the response of the web service will take some time. So you need to make your process wait till response is received, right? In the scenario, we can create a wait activity for 5 minutes or 6 minutes, something like that. So we can implement in the real-time integrations. So next one is the end section. In the end section, the first one is the throw new fault activity. You can create and throw your custom faults in the integration by using throw new fault activity, right? So you can use this activity within the for each loop and also while loop. For example, you have a two inputs parameters, number 1 and number 2, right? So you are checking a condition with number 1 greater than number 2. If number 1 is not greater than number 2, you can throw a fault action, right? And you can send a custom declaration message to the business, and also you can stop execution of the process, right? So here you can give your custom messages, right? Your code, reason code, detail, skip condition, everything we can mention in the throw new fault. So next one is the rethrow fault. This can be only used with a fault handler, right? So basically it catches the fault and throws one level up. That means if the integration contains a defined global fault, the error captured by the rethrow fault action. Okay. So next one is the return. So basically return executes an immediate response to the client application. Alright, this is available only in the synchronous integrations. Right. Next one is the callback. In the callback, the executes a callback invocation to the client applications. This is only available in the app driven style with asynchronous callback. So last one is the stop. So the stop, this stops the integration flow processing, right? So whenever in the integration flow, whenever we wanted to stop the process, we can use the stop activity. So in the real-time integration, I don't want to process further for particular one of the organization. I don't want to handle the logic for the particular organization. So I can stop the process. For that, I can use the stop activity, right? So the stop activity is not applicable in the synchronous integrations. Okay. This is all about end section.